Okay. Now I gotta do my countdown thing again. That's not gonna work out well. Alright, I'll just keep track of it. So basically at 11 o'clock. Okay. You're going to take the cursor off of, I don't know where that -1 is. Where did that come from?
I didn't put negative in.
You, let's see,
put a
a
negative
negative in
X.
there. Okay. That's what happened there. Okay, I think that'll do it. Okay, so I don't want that top one. Okay, so I'm gonna put over top of that and I'm gonna hit enter. Okay, then I'm gonna do second calculate. And it's gonna graph just those two. And I'm gonna keep hitting enter until it says intersection. Okay, so basically it's a -1.6 and 0.6. Is that what you have? Okay, now, like this one over here would be the intersection of the red line and the blue line. So this time you're doing this and that. So you're gonna highlight this one and highlight that one, and then do second calculate again and find the point of intersection between those two. So you don't want it on this one, but you do want it on these two.
Yeah,
Is that making sense?
Yeah, I was like, which one?
So you want the equals to be not highlighted on the two bottom ones, or just one of them?
Okay, it would be on that one, which is a 3/11, and it would be the x minus 7. So I want to take it off of this bottom one.
Okay.
Okay, so I just press enter over top of it, okay? And then do second calculate again. What'd you get, Joseph?
11.4.
11, oh, came out whole?
Mm-hmm.
Okay,
Think so.
go ahead and find the last one. Okay, did you get it, Vivian?
I accidentally clicked through it and then went back.
Okay. Okay, so you want x minus 7, you want, okay, so second calculate, intersect, oops. First curve, second curve, keep hitting enter.
It was doing that on my
Okay,
homework.
all that means is that your window's not big enough.
Oh.
Okay, so I wanna change the x max is what it would take. See, if it won't show where it crosses, it's gonna give you that.
Mine just keeps saying error.
Right, okay,
Okay. They kept doing that on my homework a while ago.
okay, let's see if it does it this time. Yeah, okay. Now, what that means is it won't show where it crosses on your calculator. Okay, so if you graph this thing, and it won't even graph it. Okay, it needs to go farther over to your right. Okay, so what I'm gonna do is I'm gonna change the x max, which is to the right on the x value, to 20. And now when I go second calculate and go down to intersect, still won't do it. Let me go back and look at your window again. It's that thing right there. Okay, now it should work. Yeah, now it will show it. Oops, we must have the wrong two things highlighted. X minus 7, negative x minus 1. Oh. It's not, there isn't a negative there. It's x minus 7.
Okay.
Okay. Okay, and then the third, you would do the same thing with this one down here, except for it's the red line and the purple line. Okay, does that make sense all the way through? What do you have for that?
3, -4.
3, -4. Okay, now, then you have these 3 points. Okay? Now, what I'm about to show you is what you're gonna do on the next step. Okay? The next step has to do with taking those points and plugging it into an equation. I don't think on the first section you don't have any of those, okay? All you have on the first section is basically, all you have to do is graph them, okay? Now, if you want the practice of finding the points, you can, but the points become very important in the second section that we're gonna go through. I just wanted to go ahead and teach it to you while I was teaching you putting it on the thing. All right, we're gonna do one that has a constraining thing, and then we're gonna go back and do a word problem so that you can see how you would ever use this, okay? All right, look at this one. Here's when the constraining equation is gonna look like this. Okay, it's gonna be the f of x and y, because it's gonna have a spot for you to substitute in both your x and your y's. Okay, so that's gonna be what we call our constraining equation. All right, very quickly, let's do this one. I have x is greater than or equal to 1, y is greater than or equal to 2, and I have x plus 2y is less than or equal to 9. Okay, you with me so far? I've got to rearrange this one. So I have 2y is less than or equal to -x plus 9. I have y is less than or equal to -1/2 x plus 9 over 2, which is going to be 4.5. Okay, so if I put these on a coordinate plane, and I have x is greater than 1. So that's a vertical line through 1. Greater than is going to be that way, right? Then I have y is greater than 2. So that's going to be a horizontal line. So right now, we're talking about this area right here. Okay. More color. All right, now this one, I'm going to go up 4.5. So halfway between 4 and 5. Then I'm going to go down 1 and over to the right 2. So you're talking about right there. And it's less than that. So if you'll notice, you've got 3 corners. You've got this one, and this one. Your bounded region is right there. Okay? Now, part of the problem here is that I have the y's but I also have x's. So if I'm looking for the intersection right here, I've got this one and I've got that one. I can't put that one in my calculator, so what am I going to do?
Substitute that in for the x.
I'm going to substitute it in for the x. So I have y is equal to -1/2 times 1 plus 9 over 2, which is going to end up giving me 8 over 2, which is 4, right? That's the y value. What's the x value? 1. Okay. So I have the point 1, 4. Okay. Then I come down here, and this is the intersection between the red line and the purple line. What's my value right there?
1, 2.
1, 2. Tells me my x. My x is 1. Tells me my y. My y is 2. So that one's a real easy one. This one you can plug into your calculator because they're both y's. You can do it that way if you want to. You don't have to do it that way. You could do it by hand. Okay, it's entirely up to you to do it by hand. I already know what the y value is. The y value is 2, correct? So I plug the y in and I go 2 is equal to negative 1/2 x plus 9 over 2. All right? If I want to, let me make this into a common denominator with everything else. So I'm going to subtract the 9 over 2, which is going to give me a negative 5 over 2 equals negative 1/2 x. I'm going to solve for that, which means I'm going to divide by negative 1/2, or I'm going to invert and multiply by 2 over 1, which is going to give me a positive 5. Okay? You with me so far? Okay, so I found the 3 points. Now I'm going to turn around and I've got to get some space first. But I'm going to use those 3 points to plug into that equation. So I'm going to make a table. Here's going to be my x and my y's. Here's going to be my equation. And then this third column is actually the answer that I'm going to get. And that's what it stands for, the answer. Okay, what I get when I plug the x and the y in. So I have the point 1, 4. Remember, the points are coming from over there. I have 5, 2, and I have 1, 2. Okay, so far so good. All right, so I just plug them in. 2 times 1 minus 3 times 4. 2 minus 12 is a negative 10. And then I have 2 times 5 minus 3 times 2. And so I have 10 minus 6, which is 4. And then I have 2 times 1 minus 3 times 2, which is 2 minus 6, which is a negative 4, right? So far so good? All right, what's the highest number I have over here?
4.
4. So therefore, I have a max of 4 at 5, 2. What's my smallest number?
Negative 10.
Negative 10. I have a min of negative 10 at 1, 4. Okay, that's what you're doing with this. Vivian, you with me? Sort of, kind of?
And you always plug it into that.
They're going to give you, this is going to be different every time.
Oh,
Okay, so you just look, just like your equations are different, that's going to change depending on your problem. But you look for the one that says the f of x, y. That's going to be what you plug it into. Okay? All right. All right, I want you to open your books to page 153. Okay, on 153, it's an example problem of how in life you would use this, okay? Now, these would be hard if they made you come up with the equations, but right now in your math, they're giving you the equations. Okay, so basically what you've got is you've got this guy, Harrison Grundon. He has 20 days in which to plant corn and soybeans. The corn can be planted at a rate of 60 acres per day and the soybean at a rate of 70 acres per day. He has 1,300 acres available for planting these two crops. Write inequalities to show the possible ways he can plant the available acres. Okay, do we understand? He can't plant less than 0 acres of something. Okay, you can't plant negative acres. All right, so let C represent the acres of corn and S represent the acres in soybeans. So the corn is greater than 0. The soybean is greater than 0. You can't have negative. They both have to be positive. So basically on a coordinate plane, you're saying they have to be in the first quadrant. Okay? So you're going, it's got to be greater than this and greater than that. Okay, so you've narrowed it in. Okay, then it says, since corn can be planted at a rate of 60 acres per day, Harrison can plant no more than 20 times 60 or 1,200 acres. Okay? The 20 days is how many days he has. They gave you that up there. Okay, so if you planted absolutely 60 acres every day for 20 days, okay, you're going to get 1,200. So it's going to have to be less than that. Okay, same thing on soybeans. You can do 70 acres per day, but you only have 20 days. So 20 times 70, if you planted all soybean, okay, you would have less than 1,400. So there's, right now, we've got 4 equations. Okay, then he cannot plant more than 1,300 acres of the two of them together. So now I have C plus S is less than 1,300. There's a fifth equation. All right. The last, or the constraining, is you can see that it's like he's got 20 days to plant it. The number of days spent planting each crop must be less than or equal to 20. So you have corn, and then how much you plant. You have soybean, how much you plant. So it's less than 20. So they multiply that out to get the thing off the bottom. Okay, they got rid of the fraction. Okay, so there's your constraining equation. Now turn the page. See how they graphed it? Okay, in the green, what they did was they graphed all those equations and they shaded it in the green, which means I have 1, 2, 3, 4 vertices. There's 4 corners of that green graph. Okay, so they solved that. If you scan on down, you have the little chart at the bottom. Okay, see where they plugged in the vertices? Okay, then what's your maximum profit? 36,000. If he wanted to maximize his profit, he would plant 1,200 acres of just corn. Okay, see how that's 1,200 and 0? He's going to make the most money if he does it. Okay, it's kind of a cool thing. I feel like nowadays everything probably would be computerized, and somebody else would have come up with the equations for you, and you would have just plugged it in. And so, but it's economics through and through. You know, maximize it. Maybe you're trying to find out how many workers need to work overtime to maximize your profit, okay, and minimize your expense. They would come up with these equations, you would plug them in, you would find the max and the min, and go from there. Now, they're not going to make you do that, okay, but I just wanted you to see, not this year, okay, I just wanted you to see how this is used, okay. This year, all you have to focus on is finding your max and min point. They're giving you the equations, you find your corners, you plug them back in, okay? You good? Okay. All right, I'm going to give you one of these to try, okay? Give me a second till I find a good one. I'm not even sure that they're going to give you a constraining one. Let me just give you one to find the different variables in. Let's do that first. Oh yeah, they are going to give you one. Okay, never mind, I am going to give you one. I skipped a page. I'm thinking seriously about just giving you homework on the second section, because the first section that we covered was just graphing it. Okay, so if you can graph it, you can find the corners and you can plug it in. So the second equation basically used everything from the first section and then added to it. So if you can do the second one, you can do the first one. Why waste all that time, right? Okay, let's do this. And I'll have to work this out at the same time because I don't have the answer to it. Okay, those are all your equations, and this is your constraining equation. So that's what you're going to plug in your corners back into, okay?
Yeah, it's about to turn off.
Is it?